Guided exercise number 4. Evaluate the following indefinite integrals. Number 4 is the indefinite integral of sine of 3x plus 5 dx. Now, it's a good guess that we should do this using u substitution. And if you go looking for an inside function somewhere in your integrand, it pretty much has to be 3x plus 5. So let's try that and see what happens. So u equals 3x plus 5. To get du, we're supposed to take the derivative of that. So du is going to be 3 and then dx. Remember to put a dx right there. And we have a small problem, and the small problem is this 3, because we don't have one within the integrand. And so what we can do is we can make one be there. Now, we can't just throw in a 3 because that would change the value of our indefinite integral. But we can always multiply by 1 without changing anything. So let me make that look a little bit more like a 3. Let's throw in a third and then do sine 3x plus 5 times 3 dx. I didn't change anything, right? Because 1/3 times 3 is equal to 1. So I haven't messed anything up here by throwing in a times a third and a times 3. And the advantage of doing this is that now I can find my du. So let's see, my u is 3x plus 5. And then here's my du, which is 3 dx. And so when I do the substitution, I have the indefinite integral of 1/3, and yes, you do have to keep that 1/3, sine u du, which again looks way less complicated than what we started out with. The 1/3 is maybe not great, but at least we know how to deal with it. So when we determine the indefinite integral, we get 1/3 times negative cosine of u, and then plus c. And then at the very end, we need to go back and we need to put the x's back in. So we do negative 1/3 cosine of 3x plus 5, and then plus c. And we should definitely check. So let's do a check step. The derivative of negative 1/3 cosine 3x plus 5 is negative 1/3 negative sine 3x plus 5, and then times 3. All right, so the 1/3 cancels with the 3. This negative cancels with that one. And we get sine of 3x plus 5. And that was our original integrand, so this checks out. So the basic process that we just used is the basic process that you want to use anytime that you're doing integration by substitution.